and we are going to check with other data structure. If the other data structure is taking less time, and other two factors also, like cost of operations and the fit of the data, then we have to choose that data structure. Okay, so first three things we have to understand: the first, best fit for the data, we have to choose the data structure. Then the cost operation, the frequent operation, we have to see what type of frequent operation will be performed on this data. Then the memory uses. Okay, so all this should be in a very good form. Okay, and then after that we have to choose the data structure based on that, right? Now understand first what is tree. So tree is also one data structure that represents hierarchical data. Okay, not the linear data structure like array, linked list, stack, queue, but tree is a hierarchical data structure. Like if we have to represent if we have to represent, give me 1 minute, pen. If we have to represent, like this is a employee, let's see, we can say any company we can take, right? Like I'm taking Oracle. Okay, so Oracle has a CEO, right? And what is the CEO position is there? After the, what are the president are there, right? Who is the president is there? What is the VP is there, right? Then what is like manager are there. Like this, if we are going to represent, we have to represent this type of data based on their role and based on their role and the name, right? Rank, we can also say. So in this representation, what we can say, this representation is known as hierarchical data, right? And for this representation, we have to take tree data structure. We have to take tree data structure. Okay, next we can say, okay, next, the key point of the tree data structure are what we have to follow. A tree data structure is defined as a collection of objects. Okay, first we have to understand tree data structure is defined as a collection of objects or entities, we can say, or we can say object also, right? So it is known as node. That's are known as node. So each node is a collection of object or entities that are linked together to represent the hierarchy, right? That I have just given an example. So tree data structure is a non-linear data structure because it is not we will not use tree data structure for the linear data structure. That's why it is not a linear data structure, non-linear data structure, because it does not store a sequential manner, because it will take hierarchical order, hierarchical manner. Okay, so it's a hierarchical structure as an element in a tree arranged in multiple levels. So there will be multiple levels that we will understand what is the first level, second level, and the so on. Okay, in the tree data structure, the topmost element is known as root node. So root node do not have any parents. So how we will understand this is root node? We will explain you. Give me 1 minute. So each node contains some data. Either it is a root node or any other things. So each node contains some data. Okay, there will be data, and that can be any type. So first we have to understand what type of data is this and the type, right? And then each node contains some data and link to represent other nodes. Okay, let me remove this one and I have to take the laser pen. Okay, so each node contains some data and the link of reference of other node that can be used. So first, the tree data structure is representation, as I told you. So this is the root node, right? The first node is known as root node. Okay, because the root node is the topmost node in the tree data structure. This is a tree hierarchy, right? And this first node do not have any parent, means this node is the topmost node, and that's why it is known as root. Okay, so we can say the root node is the one that doesn't have any parents like 2, 3, and any other, right? Because everyone has its parent, it is coming from somewhere, right? But one is not coming from anywhere. So that's why the node number 1 is the root node of the tree. And if a node is directly linked to some other node, it would be called a parent child relationship, parent child relationship, parent child relationship, parent child relationship. Understand? parent-child relationship. Okay. So now we have child node. So one, except one root node, everyone is a child node of each other. Okay. 2 is a child node of 1, 3 is a child of 1. So 2 and 3 we can say a child of 1. 4, 5, 6 is a child of 2. 7, 8 is a child of 3. Similarly, 9, 10 is child of 5. 11 is a child of 7, we can say. So if a node is descendant of any node, if a node is descendant of any node, then the node is known as child node. Got it? So if the parent node, if about the parent node, if a node contains any subnode, then the node is said to be parent of the subnode. Okay. So what is the sibling? Siblings are on the same level, we can say. Okay, same parents. Like we can say 2 and 3 are siblings because both have parent 1, right? Similarly, we can say 4, 5, 6 is a sibling of 2. Okay, but we cannot say 4, 5, 6, 7, 8 is sibling. No, that's not correct, because siblings is coming from 2 only and 3 only, right? Either we have to choose 4, 5, 6 for 2 and 7, 8 for 3. So these are siblings. Okay. What is a leaf node? Leaf node are 9, we can say 4, 9, 10, 6, 7, no, not 7, 11, 8, right? Because leaf node, a node that we can say doesn't have any child node, right? So 4 doesn't have any child node, 9 doesn't have any child node, 10 doesn't have, similarly 6, 11 and 8, we do not have any child node for these nodes, right? So a leaf node is the bottommost node of a tree. There can be any number of leaf node present in the tree. So leaf node can be a external node, we can also say. Okay. So if a node doesn't have any child, then we can say this is a leaf node. There is some internal nodes are also. A node that contains at least one child node is known as internal node. So for we can say 5, 7 is a internal node. Okay. And ancestor node are there also. So an ancestor node is a precedent node on a path from the root of the node is there, right? So these are, we can say these are the ancestor node, we can also say. Okay. So here we can say node 1, 1, 2, 5 and we can say 10 is an ancestor node. Okay, we can say these are ancestor node. So there is a descendant also. So immediate successor of the given node is known as descendant node. So we can say, so 10 is a descendant node of 5. Okay, immediate successor, we can say immediate successor. Okay. And the properties of tree data structure is, we can say it is a recursive data structure. So it is very famous, like recursive. What is, if we are talking about tree, means it is a recursive data structure, and it is very famous with the name of recursive data structure. Okay. So if anyone is talking about your tree, means he is talking about the recursive data structure. If he is talking about the recursive data structure, then you have to understand this is a tree. Okay. A tree can be well defined as a recursive because the distinguished node in the tree data structure is known as root, as we have already told you, right? So tree node of the tree holds a link and to all the roots of its subtree. So the left subtree is displayed in the yellow color, that we will let you know, and the left subtree can be a further split into subtree. Let's come to the video side. Yeah, now you can see that this is the left side are known as 3, 4, 7, 8 and 2, 4, 6, 5, 9, 10 are there, right? So the number, there is a number of edges we can find. Like if we have vertices, like we cannot say vertices, but we can say edges. So n minus 1, we can say, if there is n node, so there will be n minus 1 edges. Okay. Similarly, we have to find a depth of node, right? So if the depth of node x can be defined as the length of the path from the root of the node. So each contribution, one length is a path. So the depth of the node can be defined as the number of edges between the root and the node. Okay, the number of edges between the root and the node, correct? So let's come to here. One more thing, height of the node, we can say the height of the node x can be as the longest path of the node. We can go through like this. Okay, longest path. This is very simple. Leave it. Application of tree. Okay, so where we will use the application of the tree? So storing natural hierarchical data, we can say tree are used to store the data in hierarchical structure. For example, the file system. In the computer, if we are going to understand, there is a folder, inside there is a multiple folder, inside one folder there is maybe multiple files, right? The file system is stored on the disk drive. The file and folders are in the form of natural hierarchical data and stored in the form of tree. Okay, so this is the best example. You have to understand the file system is a best example of tree. Okay, so organize the data. It is used to organize data for efficient insertion, deletion, and search. Okay, for example, a binary tree has a log n time for searching an element. So what is tree? Tree is a special kind of tree that can be used to store dictionary. It is a fast and efficient way of for dynamic spell checking. Heap is also a tree data structure implemented using array, and it is used to implement priority queue. Okay, B tree and B plus tree. B tree and B plus tree are the tree data structure used to implement indexing in databases. And routing table, the tree data structure is also known as, it is used to store the data in the routing table in the routers. Okay, so these are the very good example of the tree where we will use. The first I told you the file system, then organizing the data for the searching, right? The tree is the best example for spelling check in the dictionary. Heap that is used for using array, right? Implementation of array, priority queue. B tree, B plus tree, that is used for like implementing the indexing the databases and routing in the routers. Okay, so types of data structure we have, tree data structure we have, like multiple things we have. Like in the general tree, we can say the general tree is one of the type of the tree data structure. In general tree, a node can have either 0 or maximum n number of nodes, and there is no restriction imposed on the degree of the node. Number of node that a node can contains, and the top node in the general tree is known as a root node. So the children of the parent known as subtree, we can say. Either we can take one a b c a b f we can take, or we can take a b f j, or either we can take a b c d e, we can rest of leave, or we can take all of this, right? So this is called general tree, and there are subtree is also out there. Okay, there can be n number of subtree in a general tree. So this is a general tree, and we have 1 3 2 3 3 and less than 4. Okay, we can say we can take any number of subtree in the tree. So every empty tree has a downward edge, and these edges are connected to the node known as child node, and the tree node is labeled with 0, and we can say nodes that have the same parent is known as siblings. Like we can say for the siblings we have a for the a we have b f j. So the b f j is siblings, c d e is sibling, g h is sibling, like that. Okay, so we already knows what is the child node are there. Okay, coming to, there is another tree data structure, that is binary tree. So binary tree, we can say binary tree itself suggests two number, either 0 and 1 in a binary tree. Each node in a tree can have two child maximum. Okay, so here we can say node 0 node and 1 node has two edges, we can say. So either 8 is a best, 8 have two children, 3 and 10. 3 has two children, 1 and 6. 6 has two children. But here you can see 10 has 14 and 13. Binary search tree is what we can say. Binary search tree is a non-linear data structure in which one node is connected to n number of nodes. It is a node based on data structure. A node can be represented in binary tree with three fields: data, part, child, and right child. And node can be connected to upmost two children node in a binary search tree. So the node contains two pointer, left and right. every node in the left subtree contains a value less than the value of the root node, and the value of each node in the right subtree must be bigger than the value of the root node. So we will understand this tree also. Just I am letting you know what type of data structure are there. We will go in the deep. So there is AVL tree, and there is other trees are also. Red black tree is there, and the red black tree is there also, and there is some other trees also. So like split tree data structure also. We can have a tree app data structure also. So many things are there, we will go through in the future. So this is the Wikipedia. You can understand, you can go through on the Google and you can search tree on Wikipedia, right? And over that you will find this page. So first of all, I'm going to zoom this page first. Okay, so in this page you can see there is a tree symbol is there, tree picture is there in the. So it is a level tree with 6 vertices and 5 edges. Okay, vertices means 1 2 3 4 5 6. This is the vertices, and edges is connection connected by 1 and 4 1, 2 and 4 2, 3 and 4 3, and 4 and 5 4, and 5 and 6 this one. So these are the vertices and these are the edges. Now you have got an understanding. So the, you can say in the circle we can say it is a vertices, and the line is called line the connecting the vertices is edges. Okay, so if a vertices is, if a tree has vertices v, means edges will be v minus 1. Okay, and in the chromatic order, in the chromatic number, you can say if it is 2 means v minus 1, if v is greater than 2 means 2. Okay, so this is the table of the graph, and this is the parameter, you can understand. So why this is called tree? So let's understand first. So in graph theory, in the graph theory, this is the graph theory. Okay, so if anything is there that is connect, any vertices is connecting with any other, and maybe it may connect multiple, and it may be multi-layer, you can say. So this is called graph theory. In a graph theory, a tree is a unidirected graph. Unidirected means any direction. There is no direction. It is pointing to 6 to 4 or 4 to 6, right? As 4 to 5, yeah, 5 to 4. There is no direction is there. Okay. So that's why it is called unidirected graph. Okay, so a tree is a unidirected graph. There is no direction is there. Okay, so in which any two vertices are connected by exactly one path. Okay, so any two vertices are connected by exact one path. There no direction is there. Okay, so that's why it is called directed undirected graph by only on path. What is path? Path is like the red line is there. 100 is connected by 1110, and 1110 is connected by 100. Like this, coordinates are there: 100, 101, 010, 011, 111, 110. These are the vertices of you can say Q, and Q is connecting one vertices point to another vertices point via a edge. Okay, so that's why it is called. Okay, so a connected, what is a connected cyclic undirected graph? Connected means one vertices is connected by any other, and cyclic means it is connected by one is connected by any all of them. There is no extra link that goes to vertices and not coming back. All the vertices will connected with all of the uh, no you can say vertices. Okay, and that's why there is all the vertices are connected with all the vertices available in the graph. That's why it is called connected or cyclic graph. Okay, a cyclic means, as you can see, like A is connected with B is connected to C, C is connected with, like this, and after that the A is connected with H is connected to A. So A is connected with B and H also, and any other vertices also. That's why it is called a cyclic graph. Okay, the best example is a forest. Forest is a undirected graph. Okay, because when we walk to a forest, there will be multiple paths are there. You can visit one vertices to any vertices by any of the path. It may as you can see here, a forest is a undirected graph in which any two vertices are connected by at any most path you can choose, okay, and or equivalently an acyclic undirected graph also you can visit. The first, what I have told you, if you are going to a forest, that is a undirected graph, okay. So a forest is an undirected graph because any two vertices are connected by at most one path and there is no direction is there, okay. We have to add one more thing, there is no direction is there, okay. Next, uh, you can say there is a polytree graph is also there, means a graph is a vertices is connected with more than one vertices, and there is a direction is also there, okay. So there will maybe multiple directions is there, like A is connected with C and D also, B is connected with D in E, D is connected with multiples, okay. So there may be a polytree graph also, or that is called, also we can directed tree, we can say oriented tree, we can also say singly connected network, we can also say. So all these are called a polytree, either you can say directed tree, either you can say oriented tree, or either you can say singly connected network. So all are connected as a polytree, okay. So polytree is a directed acyclic graph. Directed acyclic graph, that is in the short we used to say DAG. So DAG is a directed graph, means there is a directed cyclic graph that connects one node to another node with a direction, means from A it will go to B, from B it will go to D, from D it will go to any other points, okay. That's why it is called a directed graph. So a polytree is a directed acyclic graph, that is called DAG. There will be a direction, okay. So polyforest, there is a best example, that is a polyforest. So polyforest means there is a directed forest, there is a on oriented forest is also. So it's a directed acyclic graph whose underline we can say directed graph is a forest, okay. So as simple as that, you can also say a polytree is uh, a underlying we can say undirected uh, graph or tree, we can also say, okay. So that's why it is saying the polyforest is a directed or cyclic graph whose underlying directed graph is a forest. So a forest is also a tree, we can say, sorry, polytree is say. So we have to understand very uh, basics, okay. So a tree is a undirected graph, a tree is a undirected graph, that is called G as a symbol, that satisfy any of the following conditions. So a graph G is connected on an acyclic, there is that contains no cycles, okay. So G is a cyclic and a simple cyclic form, okay. So either it is connected or either it is a cyclic, so it can be both, okay. So that is called a graph is connected and a cyclic, there is no cycles, that contains no cycle, okay. That is why call it is a tree. Graph, that is called undirected graph, right? Tree is a undirected graph and represented by G, okay. So G is a cyclic and a simple cycle form if any edge is added to G. Very simple form, okay, very simple cycle form. So G is connected but would become disconnected if any single edge is removed from G. If we remove any of these, so it can be disconnected, okay. So we cannot remove any of the edge in a tree, otherwise it will be disconnected. G is a connected and three vertices complete graph. Complete graph is, this is a complete graph, it is connected by each of the vertices by more than three, okay, and can be a three vertex complete graph. So K3 is not a minor of G, it is not a minor of G. Minor means a graph as undirected graph H is called minor of the graph if H can be formed from G by deleting edges and vertices by contracting edges. So this is not a minor of graph. So this is a complete graph. So any two vertices G can be connected by unique simpler path. Okay. So if G has a finite many vertices, say n, say n of them, and then our statement are equal and equivalent of any of the following conditions, okay. So G is a connected and has, we can say, n minus 1 edges, we can say. And if G is connected, so every subgraph of G include at least one vertex with 0 or 1 incident edges. So G is a connected one degenerated graph. Okay, G has no simple cycle and has n minus 1 edges. Okay, that is a very simple things. Now you can go to understand what I told you in the while discussing what is edges, what is forest, what is polyforest. So you will understand. Okay, so I will share this link and go through by your own. And if you have any doubt, please ping me in the comment box.